Okay, we're going to look at rational exponents, which are not brand new to you. Rational exponents just mean that they are fractional exponents. Okay? Different ways to write our radicals is one way to look at it. So when you want them completely simplified, then you have no negative exponents, no fractional exponents, which means we've rewritten it in root form, no complex fractions, that's fraction and a fraction, which we try to avoid as much as we can anyway. The index of any remaining radical is the least number possible. So the index is like if it was a cube root, that 3, that's the index. So terminology, you know what we're talking about. And then the base is always written as the smallest number possible. So we'll go through and we simplify these, make sure all that stuff is true. So here's the rational exponent form, and here is the radical form. So if I have b to the m over n power, it's a fraction. The denominator of the fraction is the index of the root, and the numerator is the exponent, which can become either it can be either inside or outside the root, the radical, just depending on maybe which way makes more sense for that question or which way is easier. It doesn't matter either way. Okay, so 7 to the 1/2 power, same as the square root of 7. 5 to the 2/3 power, see that 3 became the index, and then that 2 is the exponent, and we could write it either way, right? And then just these other ones here. This one I want to point out, we have 8 to the 4/6 power, but it looks like this because you have to reduce that fraction, reduces to 2/3, and that's why your root looks like this right here, okay? So fractional exponents look familiar, right? Not brand new to you. Okay. Let's talk about how we handle that. Actually, first, I'm going to go back up here and ask you a question. If I have x squared times x cubed, what does that give me? X to the 5th power, right? Do we all agree with that? Sebastian, you agree with that? You'll stop talking. Okay, because our rule is when you multiply two things with the same bases, you add the exponents, right? You need to remind yourself that that's the rule, because I know you know that rule, but then you don't do that rule when things start to look different. So when we are right here, we have 16 to the 3/4 power times 16 to the 1/2 power. I have the same base, so I'm going to keep the base and I add the exponents. 3/4 plus 1/2. Okay, that makes sense? Now, I'm going to come off to the side because I think I know some of you could do it all in there, but I think that confuses some people. If I'm going to take 3/4 and add it to 1/2, what do I have to do to be able to add? Get a common denominator. So I'm going to multiply this by 2 over 2. So that becomes 3/4 plus 2/4. And then that becomes 5/4. Everybody okay with that? So that means that this is 16 to the 5/4 power. Okay. Everybody okay with that? Now we're going to pause on that for just a second. Going to come back up here where we have some more room. And if I have the cube root of x to the 5th, okay, and I need to simplify that. Okay, this is what we've already done when we did radicals. And I want to see, can I bring any x's out? How many x's can I bring out? Just one, because I look at 3 goes into 5 how many times? Once, right? So 1 x gets to come out, and then there's 2 left over, so 2 have to stay in. Does that make sense to you? That's what we've already done with the roots. Now we're going to do the exact same thing, but look at it as a fraction. So I have x to the 5/3 power, right? And then we're basically going to do the exact same thing. 3 goes into 5 how many times? Once. And then we have 2 left over, so it would be to the 2/3 power. So we have x times x to the 2/3 power. You see how we split that? Okay, you're splitting it the same way we did for the roots. It's just not in root form. Okay, because if you think about this, even though we don't write fractions like this, well, we do write this. 5/3 is equal to 1 2/3. Do we agree with that? That's the mixed number. This is actually 1 plus 2/3. That's not how we write mixed numbers, but that's what we're doing. We're putting cups of flour in there. We put 1 cup plus another 2/3 cups, right? So here, if I add the exponents, I get that back, which is what I'm trying to do. So all I'm trying to show you right here is what we've already done with roots. We're going to do the exact same thing with the fractions. Okay, you're thinking of them as roots. So when I'm back down here, and I have 16 to the 5/4 power. 4 goes into 5 how many times? Once. So 16 to the 1st power gets separated out times 16, and then there's 1 left over to the 1/4, because 5/4 is the same thing as 1 and 1/4. Okay? I'm making that fraction into that improper fraction into a mixed number. Everybody good so far? All right, so now 16 to the 1st is just 16 to the 1st. So 16 times the 4th root of 16. Now I can simplify it, like I can do a little tree here, and that's fine, but taking the 4th root of something is actually very easy. You just take the square root, and then you take the square root again. So the square root of 16 is what? 4, and then the square root of 4 is 2. So the 4th root of 16 is 2. We get 16 times 2, and that's 32. Okay. What questions do you have? Anything about where anything came from or anything at all? If I lost you somewhere, say something. We're all good? Okay. Let's look at this one. All right. I have a negative exponent. I'm not going to worry about that so much just yet. I'll worry about it in a minute. But notice here my bases were the same. Here my bases were not the same. So I need my bases to be the same for me to be able to do anything. All right. This is 4. Can I change 16 into 4 to some exponent? Yes, I can. So I can make this into, I'm going to leave this as 4 to the negative 3/2 power times, instead of 16, that is 4 squared to the 1/4 power. Okay, I just made that 16 into 4 squared. Everybody with me on that? Okay. Now 4 squared is 16, but I'm not going to write that down or I'm going in circles, right? The whole idea is that I want 4. If I do a power to a power, I multiply, right? And 2 times 1/4, oh God. Okay, so before we were so rudely interrupted, listen, I took this 16 and I made it into 4 squared. So if I'm just looking at this fraction or this exponents, our power to a power rule means we're going to take 2 times 1/4. That gives me 2/4, which is what? 1/2. Okay. So now I've got now my exponent's going to be 1/2. So now I have 4 to the negative 3/2 times 4 to the 1/2. What do I do with the exponents? Add them. So that's going to give me negative 3/2 plus 1/2. That gives me negative 2/2, which is negative 1. So this becomes 4 to the negative 1 power. What is 4 to the negative 1 power? No. So confident, but no. It's not 0. No. What does the negative in an exponent do? It moves it from the numerator to the denominator and vice versa. It is 1/4. I knew that. I just wasn't at that spot. You got it. Okay, so I've heard I both times today. That's when we take the square root of a negative number, and we're not doing that. I get 0. Well, I never get 0, but I would get 1 if I took something to the power of 0. Oh, did you get that? Yeah. You know where did I lose you? Yeah, you're refocusing. Do I need to talk back through this? No? Okay. Okay. All right. Are we good then? All right. Yes, I'm well aware. We've already fractions are rough. They're not going away though. All right. So here, I again need to get the two bases to be the same. So the denominator that is 2 is going to stay 2 to the 3/4 power. And then I can change 8 to 2 to what power? The third. Yeah, 2 to the third power is 8. All right. When we multiply two things with the same base, we add the exponents. When we divide, what do we do with the exponents? Subtract. Very good. So we are going to take 3 and subtract 3/4. Okay. What do we have to be able to subtract these? Common denominator, which will need to be 4. So I need to multiply this one by 4/4. That will give me 12/4 minus 3/4, which gives me 9/4. Now, I had a really hard time explaining this to somebody on one of the questions on the assignment earlier today. When you do, the 2's do not cancel out and become 1. If they were just a plain old 2, yes, I mean, because they're just the same thing. But it's just the base stays the same. The base is still 2. All we did was subtract the exponents, and now I have 2 to the 9/4 power. Okay, everybody okay with that so far? All right, so now we're going to split it up. Basically, to split it up, you take that fraction and you make it into a mixed number. Okay, so 4 goes into 9 how many times? 2. So that's the exponent on the first one. And then after it goes in there twice, what do I have left over? 1. So it'd be 1/4. So 2 and 1/4 is the same as 9/4. Does that make sense to you? And then that means that what is 2 squared? 4. And that's going to be 4 times the 4th root of 2. And that's all we can do there. And that is it. Okay. Ask me a question instead of just giving my board dirty looks. Where did I lose you? Because 2 to the 1/4 is the same thing as the 4th root. Just like 2, like if it was to the 1/2 power, it's a square root. If it's a 1/3 power, it's a third root. Okay. What else? Any other questions? Okay. We're actually stopping there. I'm going to give you your assignment. You're only going to have to do 5 questions. After I hand this out, pay very close attention because I'm going to tell you to take one off, or I'm going to tell you which ones to do and what to change. Okay. And if you're doing the wrong thing, that's on you. They're not wrong. I just want them to be different. Okay, does everybody have one in front of them? All right, I want you're going to just do that top part, that 1 through 6. That's all you have to do, but you don't even have to do number 4. Mark off number 4. And change on number 6, change that 24 to 36. Okay, so you're eliminating number 4, and on number 6, you're changing 24 to 36. Does that make sense? All right.